Welcome back, everybody, to another video lecture by Miss Simoneau. This afternoon, we're going to be talking about chemical reactions and equations, and really specifically about balancing chemical equations. So that's the main topic tonight, is how to balance a chemical equation. So for my honor students, this is Chapter 8. For my regular chemistry kids, this is Chapter 11. Again, I always suggest that you read the pages in your textbook if you're having difficulty with the content in this video or the activities that we're doing in class, or it's always a lovely review before test time. So the first thing to know about is what is a chemical reaction, and this is a process in which one or more substances are converted into a new substance with a different physical and chemical property. And this should sound kind of familiar when we've talked about chemical changes before. We're basically talking about a chemical reaction occurring here, and so we're having one substance into a new substance. So really basically, when we're talking about a chemical equation, we write it with two main parts. We start off with our reactants, and then we also have our products. Our reactant or reagent is the substance that enters into the chemical reaction, and then our product is a substance that is produced by a chemical reaction. And a very simplistic way that I always tell my students is, I use the pancake example. Here, our reactants are our ingredients. So if I'm making pancakes, I have water, I have an egg, I have some powder from the box. So these are all my reactants. I go ahead and I apply some heat, and afterwards it yields. Okay, remember this arrow is a symbol for yields, and I'm going to apply some heat, so I'm going to put the little symbol there. It yields a product of pancakes. So pancakes is my product. So my ingredients or my reactants are my starting materials, and the final thing that's produced, pancakes or the product. Now, one of the things that we need to do before we start actually balancing chemical equations is to practice with word equations. So the idea here is we have words instead of our chemical formulas in our equation. So we have calcium and oxygen, and they're going to yield, here's your arrow again, I know it's a little weird looking on here, they're going to produce calcium oxide. So these are our reactants, okay, and this is our product over here. And the way that we should correctly read this is that calcium reacts with oxygen to produce calcium oxide. We also can say to yield calcium oxide as well. So now one of the big ideas from this chapter is that we need to be able to correctly balance chemical equations. So very importantly is that the number of atoms of each element must be the same before and after a chemical reaction. After we already have our formulas written out, our chemical formulas written out, we're going to use coefficients to help us balance the number of atoms on the reactants and the product side. So a coefficient is a whole number placed in front of a formula to balance the number of atoms on each side of the equation. So when we're balancing, we're only using coefficients. So we're going to go ahead and start off by looking at these two, this equation here. It's unbalanced, meaning that we don't have an equal number of atoms on each side. So we've got calcium reacts with oxygen to yield calcium oxide. So a second ago, I believe we saw this word equation for this. So we have got calcium reacts with oxygen to produce or yield calcium oxide. And what we're going to want to do is notice how we've added two coefficients here. The coefficients are out in front of the chemical formula. And the idea behind this is, if we look at the equation up here, I've got one calcium on the reactant side, one calcium on the product side, so that's good. But then if I look here, I've got O2, and remember these 2's always get messed up in these videos, so it's like a subscript here, so it's O2. We have two oxygens on this side and only one over here. So in order to get two oxygens on the product side, we need to put the 2 in the front. But now that's given us two calcium, so now we need to put a 2 over here. So you know me, I always like to have steps or know exactly how I should be doing something. So the steps here for balancing an equation is to write the unbalanced equation. Sometimes you'll hear me call this a skeleton equation because it's just the bones. It doesn't have the meat or the coefficients there. We need to count the atoms on each side. We need to add coefficients to make the numbers equal. So here, a coefficient is not the same as a subscript. Remember, a subscript tells you the number of atoms that are there. A coefficient goes out in front and it tells you the number of molecules, but it also can be multiplied out to tell you the number of atoms as well. You also need to reduce the coefficients to the lowest possible ratio if necessary, and double check that the atoms balance on both sides. So here's a good basic equation to start off practicing balancing and writing our chemical formulas. So it says water reacts with carbon dioxide to produce glucose and oxygen. So water reacts with carbon dioxide is going to be our reactants, and glucose and oxygen are going to be the products. So we know the formula for water is H2O, reacts with carbon dioxide, CO2, and yields or produces glucose. The formula for that is C6H12O6, and oxygen. And remember, oxygen is a diatomic molecule, so I need to write O2 there. Now notice I've added these down here at the bottom. These aren't necessary to use, but these are going to help me keep track of the number of carbons, oxygens, and hydrogens. So let's go ahead and count how many of each element we have on each side of the reaction. So on this side, on carbon, I have 1 carbon on the reactant side, and I have 3 oxygens. And if you're wondering how I came up with 3, I've got 1 here and then 2 here, so I've got 3 oxygens. Then I also have 2 hydrogens. Then if I look on the product side, I have 6 carbon, I have 6 oxygen, but plus 2 more, 6 oxygen plus 2 more, so that's going to give me 8, and then I have 12 hydrogens in all. So remember, when I go to balance a chemical equation, I usually want to save oxygen and hydrogen for last. It just makes things easier. So let's go ahead, and I have 1 carbon on the reactant side, 6 carbons on the product side. So I do not want to add a subscript here, so excuse me, that would be bad, that's why I'm putting a little cross. We only can use coefficients. So to get 6 carbons on the reactant side, I'm going to have to put a 6 coefficient out front here. So now this does give me 6 carbons, but now it also gives me 13 oxygens. And you're like, 13 oxygens? 6 times 2 is 12, plus this 1 we have over here still. So I've got 13 oxygens. Okay, well that looks good. 6 and 6. Okay, good, they're balanced. Now let's look at the oxygens. 13 and 8. Wow. Just off the top of my head, I cannot think of anything that those guys are going to have in common, like a good number. So let's skip it and hope we come up with something good with hydrogen. Okay, so on the reactant side, I've got 2 hydrogens and 12 hydrogens on the product side. Yes, I can think of a number that's going to be common between them, a 6. If I take 2 and multiply it by 6, I can get 12. So let me come on over here, and I need 12, so I'm going to put my 6 out front here. So now I do have 12 hydrogens, 6 times 2. Okay, good. So these are balanced. But now this just altered my number of oxygens. And so let's go ahead and count how many oxygens we have on the reactant side now. I have 6 oxygens, so 6 times 1 is 6. And then I had 12 over here. So what does that work out to be? 6 plus 12 is, now I have 18 oxygens. Wow, that seems like a lot. Now, anything between 8 and 18? No, nothing really serious. But I do have this oxygen that's kind of hanging out by itself. So if I have 6 oxygen and I need to get to 18, 18 minus 6 is 12. So if I put a 6 here, I can make that 12 oxygen. So let's see if this is working out. 6, 12 plus 6, is that 18? Yes, finally all of our numbers are the same on both sides. So our equation is balanced. So the correct formula for photosynthesis is 6 molecules of water react with 6 molecules of oxygen, produce 1 molecule of sugar or glucose, and 6 molecules of oxygen. Finally done. A few helpful hints for balancing chemical equations is to balance one element at a time, update all atom counts after adding the coefficient. So on the last example, if I added a coefficient, I immediately changed the number of atoms on each side. If an atom appears more than once per side, balance it last. So I hope you notice that we balanced oxygen last. I think this is a good rule. And then balance polyatomic ions as single units. This is going to save you some time in just balancing. And at first you might want to simply balance it as S and O, but when you get the hang of it, you can balance it as one entire polyatomic ion. So here's another example that I want to go ahead and walk you through. We have aluminum and copper 2 chloride reacting to yield copper and aluminum chloride. So let's go ahead, and the first step is to write the basic or the skeleton equation. It says aluminum. It doesn't mention anything about it being an ion, so I'm just going to say Al plus copper 2 chloride, so CuCl2. And in case you're trying to figure out, like, well, did you write this formula? Copper has a 2 plus charge. We know chloride has a 1 minus charge. So we're going to need 2 of these, okay, 2 times -1 to balance out the charge there. And it's going to yield copper. Again, it doesn't say anything about being an ion. And aluminum chloride. So this is going to be AlCl3. Aluminum has a 3 plus charge. Chlorine has a 1 minus charge. So you need 3 chlorines to balance out the 3 positive charges in aluminum. So now that we have a equation written, our skeleton equation written, let's go ahead and we can add these in the bottom here just as a way to keep our number of atoms organized. So I'm writing aluminum, copper, and chlorine for the reactant side. Then in the same order. That's also important. At least it helps keep me on track on the product side. So if I look on the reactant side, I have 1 aluminum, I have 1 copper, and I have 2 chloride ions. If I look on the product side, I have 1 aluminum, 1 copper, and 3 chlorines. And so it looks like we have the same aluminums, the same number of coppers, but we have a different number of chlorine ions here. And so what we're going to need to do is to balance them out. I think of the lowest common denominator between 2 and 3, and so that's going to be 6. So I am going to put a coefficient of 3 in the front of our copper 2 chloride here because that will give me 6 chlorines now. But notice that also does change my number of coppers on the reactant side to 3 coppers. Over here, I need to put a 2 in the front because that'll now give me 6 chlorines, so 2 times 3 is 6. But now it also does change my number of aluminum atoms that I have, and so instead of a 1, this is going to be a 2 on this side. Now this doesn't look like it's balancing out very well. So I have 1 aluminum atom on this side, 2 on this side, so I'm going to put a 2 coefficient out front here. Now I have 2 aluminums, so good, these are balanced. But I still have an awkward number of copper atoms on each side, an unequal number. I have 3 and then 1. Oh, I just noticed something that I should have done a second ago. There was 6 chlorines on this side because the 3 times the 2 was 6. I didn't change that. So, okay, so let's come back here to this copper. So I've got 3 on the reactant side, only 1 on the product side. So I need to put a coefficient of 3 in the front. Now this will give me 3. Now it's the same, 6 and 6. Yay, we're finally balanced. So what we have again is we have 2 aluminum atoms reacting and 3 copper chloride formula units reacting to produce 3 copper atoms and 2 formula units of aluminum chloride. Okay, so I hope you guys that helps with your balancing of equations.